Hi and welcome. It's Math Mastery Mind, and here is the video you have been waiting for: integration. So the word integration with this particular symbol, integral, and this integral is just like the elongated x. I mean, when you stress the s, suppose you attach a spiral spring, then you stretch it, so it looks like the s that you stretched. And what does it mean? Integration is the reverse process of differentiation. And with this particular formula, if you have integral of x raised to power n dx equals to x raised to power n plus 1 divided by n plus 1 plus c. Remember, we integrate with respect to s, not n. N is just like power, and the c is a constant which must be added to it. And let's see this first example by following the formula above. We have x raised to power of 4 dx, which is equivalent to where this 4 is known as the n, which is equals to 4. And by applying it in this formula, we are going to have x raised to power of 4 plus 1 divided by 4 plus 1 plus the constant. So just follow the formula above and input all this value, and equals to x raised to power of 5 all divided by 5 plus c. And if you integrate this x raised to power 4, you get this. But what is the origin of this? Because we define it as the reverse of differentiation. This x raised to power 5 divided by 5 is known as, we call it the real expression that has undergone the process of differentiation. All right, why this x raised to power 4 is known as the real derivatives. So you differentiate x raised to power 5 divided by 5 plus c, and it gives you x raised to power of 4, and you integrate x to power of 4, it gives us d. So which means both are the reverse process of another. But let's consider this. If you have d divided by dx bracket x raised to power of 5, as in I want to differentiate this x raised to power 5 divided by 5. Differentiating this, we are going to have 5, which is, we take 5 down, x raised to power of 4 divided by 5. By cancelling this 5, we are going to have x raised to power of 4, which is the result of our integration. So we integrate this, we get it. So that is, the two are the reverse process. Let's see the second example. These three here, we just take it back. It serves as the coefficient, so it doesn't have anything to do with the integration. Just take it out first, and we are going to have this. If the value of this n equals to -2, by applying the formula we have used above, we are going to have 3 bracket x raised to power of -2 plus 1 all divided by -2 plus 1 bracket plus the constant. Constant is very important when you are integrating, equals to, we have 3 x raised to power of -2 plus 1, that is -1, everything divided by -1. And here we are going to have plus above, so plus divided by minus is going to be negative. We have 3 raised to power of -1, then plus the constant of integration, which is very, very important. And here is how to solve it. Now we have the forms of integration, which are the definite integration, and it has an upper band and the lower band. If you are dealing with definite, it is upper band and the lower band. That is, it must get to a certain point that's going to stop. So you integrate, then you keep inserting the value. That is, in a definite integral, you are going to get a constant value. So I know if you differentiate, if you integrate x raised to power n, so we are going to have this. But after you have this, you are going to make sure to substitute the limit. I mean the upper and the lower limit, and the lower limit is always less than the upper limit. All right. Why indefinite integral? It has no limit at all. I mean, the value you are going to get is indefinite. So only the variable will be given, no value assigned to it. All right. And if you integrate this thing as well, you are going to get this value plus c. Remember, if you have the indefinite, you are going to add c. But when you are dealing with when you are dealing with a definite, you are going to cancel the c. All right. So indefinite we have c, definite we have no c. And here is the end of the first phase. let's wait for the second one. Hello and welcome to another episode, which is the constant of integration. And in some cases, you may ask to define to determine the constant. All right. So here we want to show ourselves the importance of the constant of integration here. Suppose we are given this required to integrate this. We have 4. We take it out. Integral of x raised to power of 3 dx. And by integrating this, we have 4 x raised to power of this is going to be 4 divided by 4 plus the constant. So if 4 cancel 4, we are going to have x raised to power of 4 plus c. But from the given parameters, we have I is 3, s is 2. So we are going to put it in this. And here we have 3 equals to s, uh, that is 2 raised to power 4 plus c. And by doing the normal calculation, 2 raised to power 4 is 16 plus c. And to find the value of c, which is the constant, we are going to take 16 to the other side as negative. And here we are going to have c equals to 3 minus 16, and c equals to the negative 13. That is the value of c. But from the value of I gotten above, which is I equals to s raised to power of 4 plus c, and we have gotten the value of c, which means we just substitute it directly, and we have I equals to s raised to power 4 minus minus 13. All right, so we have minus 13, and that is the value of c. So which means if you differentiate this, you're still going to have c cancelled. And that's how to get the value of c. And the next thing we are going to do is the integration of polynomial. And polynomial is a value of power starting from 3 of what. And to do this, it's very simple. What they are going to do is just keep separating this with different integrals, since this is positive. All right, so but let's see how to write the question again. We write the question as this, and we put the x at the back. And here we start separating this integration with different variable we have. And here we have this plus we still have integral of 5x squared dx minus we have integral of 2x dx. And here we have the last one, which is plus integral of 7 dx. All right, so we start integrating this, and we have 4x raised to power 4 divided by 4 plus 5x raised to power 3 divided by 3 minus 2x raised to power of 1 plus 2, that is 2. All right, because it is 1 here, but by adding 1 we are going to have this. So plus 7x, no power. All right, so the power is 1. If you still divide it by 1, you still get the same thing. And if you have x raised to power 0 is 1. All right, so that's how we got x attached to this 7 plus the constant of integration. And here we have 4 cancelled, and we have x raised to power 4 plus 5 divided by 3, x raised to power of 3 minus, if 2 cancelled, then we have x raised to power 2 plus, so here we have 7 x raised to power 1 plus c. And that's how to get it. And let's see the second example. But this one comes plainly in only alphabet. And if you are given I equals to integral of ax raised to power 3 plus bx raised to power 2 plus cx raised to power of 1 plus d, all divided by x, and bracket the x. All right, so to do this, we are going to divide each term with the division. All right, so that is the divisor, which is x. But by doing so, we have this input plus cx divided by x plus d divided by x, and everything in the x. And we are going to start dividing this. Integral of here is ax squared dx plus, and here is integral of bx plus integral of c, and plus integral of d. And I'm going to bracket this because all of this must come with the derivative, which is the dx. So bracket this and put this is divided by x, and everything in the x at the back. So which means I'm multiplying this bracket only with the x, and here we have ax raised to power 3 divided by 3 when you integrate it, plus here is bx raised to power 2 divided by 2 plus here is cx, and here is plot. So this is another case. We have this is as integral of d divided by dx. All right, and what we are going to do here is, so we write this thing as ax raised to power 3 divided by 3 plus bx raised to power 2 divided by 2 plus cx plus, so if we take d out, what remains here is ln x. That is, we are going to have 1 divided by x, and if you integrate 1 divided by x, you are going to have logarithm of x, which is the ln x. And so this is the expression to it and how I got that one. So, and you can still have it at log of e of x. So that is it, and this is how to solve it. Thanks for watching, and wait for the next episode. Hello and welcome. Here I want to show you some standard integral, and we'll be given the expression. I want to integrate it. So the first one is x raised to power n. The result is x raised to power n plus 1, and divided by n plus 1 plus the constant, which is very, very important. And provided that this n is not equals to minus 1. All right, if n equals to minus 1, so it will not work. All right, because we are going to have an undefined equation. All right, so because if we define anything with 0, we are going to have undefined. So that is why n must not equals to minus 1. While the second one is 1, so if you integrate 1, you are going to have x. All right, so just like you multiply x in there, the x with 1, and x multiplied by 1, that is x plus constant. And this next one is integral of a, and that is you multiply x with a, which is ax plus the constant, and followed by integral of sine x, that is minus cos x plus the constant, and followed by cos, which is the sine x plus c. They are just like the opposite to differentiation, and sec square x is tan x plus constant, and followed by exponential x. If you integrate exponential s, so you're still going to get exponential s, just like the differentiation. And the next one is a raised to power x. By integrating this, we are going to have a raised to power s, everything divided by ln a, then plus constant, just like differentiation. If you integrate 1 divided by x, that is ln of x. Note that ln is still logarithm, natural logarithm. And if you integrate this 1 divided by x minus 1, it is ln of x minus a plus c. Why this one is 1 divided by a minus s? So what separates is x starts here, s end here, and this one will take negative of a minus x. So these are the standard integral for the basic, and yeah, you should know this. Thanks for watching, and wait for the next episode. Hi and welcome. Let's see the function of a linear function of x, and this one is more of the chain rule that we know in differentiation. And the rules that bounded this is that it must be linear expression. The linear expression in the sense that the power of this x must be 1. So if the power of x must be 1, we are going to use this method I'm going to show you right now. All right, so if the power is not 1, you cannot express, you cannot use this as in the power of this x. I mean the x, not the entire power. The entire power must also greater than 1. Okay, so if this case is happening, we are going to apply the U substitution. What I call it, the U substitution. So the U substitution in the sense that we are going to let the entire of this bracket to be the value of U. Okay, so by letting this 3x plus 2 to be U, we are going to have this as U equals to 3x plus 2, and y this one becomes y equals to integral of u raised to power of 4 dx. And the next thing is we differentiate this. When we differentiate this, we are going to have the u divided by the x equals to 3, and we make the u the subject, and we are going to have the u equals to 3 dx. And from this given y equals to integral of u raised to power 4 dx, you know we have the x, so we cannot integrate. So the best thing is to find what suits this from this. So that is, we are going to make this the x the subject, and by this we have the x equals to the u divided by 3, and anywhere we see the x here, we replace it with the u divided by 3, and we have y equals to and integral of u raised to power of 4, but the x here is the u divided by 3, and this 3 is 1 divided by 3, all right? So we are going to take it out. That's as 1 over 3 and integral of u raised to power 4 du. Now, we can now integrate with respect to u, and here we have 1 divided by 3, u raised to power of 5 divided by 5 plus the constant of integration, and y equals to, if you multiply this, u equals to 3x plus 2 as we are given above, and divided by 3 multiplied by 5, that is 15 plus constant. And here's the solution for this, and we call it U-substitution. And let's see the second example. You see that the power of this one is 1, all right? So we let it to be u, and by doing that, we have u equals to 5x plus 2, and we differentiate. We are going to have this as 5 x, sorry, yes, 5 du, all right? uh by making the u the subject formula, we have the x divided by 5, and by putting this thing here, we are going to have I equals to integral of exponential u dot, and the value of the x here. So when we come down here, we are going to have the u divided by 5, and we need to change something here because here is the x and here is the u, all right? And by integrating this one, we are going to have this result of the output to be all right. So this is the u, this is the x, and this is the x, and this is the u, okay? And by coming here, we have I equals to, we take out 1 over 5, and here we have the integral of exponential u, that is still exponential u according to the standard, and I equals to 1 divided by 5 exponential, but what is u? That is 5x plus 2, and everything plus constant. So here is the result. Let's see this one as well. If you are given this, we let u to be equals to 3x, all right, and the u equals to 3 dx, and by making the x the subject, we have the u divided by 3, and by putting it here, anywhere we see 3x, we replace it with u, but this one is what is a definite integral, so we have k equals to integral of cos u dot du divided by 3. We have 0 to pi over 3, and the next thing is we have k equals to 1 divided by 3 and sine of u. If you integrate cos u, that is sine u, then don't forget to have the constant, and here is the definite integral from 0 to pi divided by 3. So the constant will soon go, all right, but let's see how it will go. So we are going to take the limit of the upper and the lower, that is the upper minus the lower, at u equals to pi divided by 3. We are going to have 60, all right, plus this minus 1 over 3 sine of 0, and minus c as well. Then we have k equals to, for this we are going to have sine of 60, that is root 3 divided by 2 divided by 3 as well, and for here c we cancel c, sine of 0, that is 0, or infinity. So we are going to have k equals to, if this follow the reciprocal law, we are going to have root 3 divided by 6, and here's the result for this. We get the values, not what we have here. All right, you are welcome again. So let's see this, and here is integration of this form. We have the expression and the derivatives with product operation. What you are going to do here is, you see that here, which is the one we are going to differentiate as the expression. If you differentiate this, we have this, all right, and if you take out 2, we are going to have x plus 1, so which is equivalent to something like this, all right. And here we are still going to apply the U substitution, and so this one is the derivative. And by letting this one to be U, all right, so we are going to let the expression to be U. So because if we differentiate that one, is going to cancel the derivative. And if a question is given like this, what we are going to do first is we let, all right, we let this one equals to U. We start differentiating, all right. So we have the U equals to 2x plus 2. By making the U the subject, we are going to have 2 bracket x plus 1 when we factorize, then the x. We divide both sides by 2 into bracket of x plus 1 as we make the x the subject of the formula. And here we have 1 divided by 2 bracket x plus 1, and everything multiplied by the U. All right. So now we start input the value here. Here we have I equals to integral of here is x plus 1 bracket, and this one we have let it to be U. Then dot, what is the x? So the x is equivalent to the 1 over 2 bracket x plus 1, then the U. And if these two cancel, we have I equals to 1 over 2 will come out, then it's left with integral of U du. And by integrating this, we have 1 over 2 U raised to power 2 divided by 2 plus the constant. And the next thing here is 2 we multiply 2, that is 4, and the value of U is given as x raised to power of 2 plus 2x plus 3, and everything plus constant. Here is the result for this one. And let's see the second example, but this one comes in form of trigonometry, and this is more tricky, but let's be patient. And here we have, if we differentiate sine, we are going to have cos. All right. And if we differentiate cos, d divided by the x of cos, we are going to have minus sine. All right, from this, which one give the direct differentiation? That's the sine. But that one also give, but it comes with negative, so which means we are not going with that. We are going with the one that give the direct differentiation without any manipulation. So which means we are going for u equals to we are going to take u equals to sine of x. And when we differentiate this, we have the u equals to cos x dx, and by making the x the subject, we have the u divided by cos x. And we start substituting to the question, and we have this as integral of sine is our u. We have u dot, and what is the cos? The cos here is given as we are going to have the cos to be cos as well. Then we have the u divided by cos x as the value of the x. If these two cancel, we have the next thing to be u du. By integrating this, we are going to have u raised to power 2 divided by 2 plus c. And don't forget the value of u, which is sine. We put it in the solution here as sine of x, l raised to power 2 divided by 2 plus c. You can leave it here, or you can let it be in the proper form as sine square x divided by 2 plus c. And that is the result. And the next one is integration of this form. We are going to have derivative at the top and the expression at the denominator. That's it, numerator and denominator. So to do this, we must make sure that if we differentiate the denominator, it must give a result of the numerator. Then we apply this form. Now, by differentiating this with respect to x, we are going to have uh, 3x raised to power 2, and we have x raised to power 2 where x raised to power 2, which can cancel. Then we can go for this. So we let u equals to x raised to power 3 minus 4. Mind you, it's not necessary to use u, you can use any other letter. By differentiating this, we are going to have 3x raised to power 2, and we make the x the subject of the formula here. And by doing that, we are going to have the u divided by 3x squared, as I've been doing above. You can try that one out. And here we have integral of x raised to power 2 divided by, we let this one to be u dot y dx is du divided by 3x squared. If these two cancel, we are going to have in 1 divided by 3, all right, integral of 1 divided by u du. But if we integrate 1 over u as from the standard, we are going to get ln u. We have 1 over 3 ln of u plus constant. But don't forget the value of u as x raised to power 3 minus. So we just put it here and we get the value. Here is how to do it. Thanks for watching and wait for the next episode. You're welcome. Let's see this the integration by changing a variable, because in some cases you might have the power, the numerator power and denominator power to be the same. When you have that, the best solution is to have the changing of variable. You know, if we differentiate this denominator, we are going to have 1, and 1 does not equals to x. And in this case, there is a way out to every problem in integration. What we do is we are going to change the variable. All right, but let's see how to do it. We are given this question to integrate. The power are the same. All right, the power are the same. So what we are going to do here is we are going to let, all right, so we are going to let the denominator to be u as we did earlier, but we change the variable during the process by letting u equals to x plus 1, and we can still make x the subject here, and we have x equals to u minus 1. And if x equals to u minus 1, so the one that we let as the new formation, we are going to differentiate it. That is, the x equals to, and here if you differentiate u, that is the u, then we later cross multiply, we still have the x equals to the u. And we now back to the real question, and the question states integral of, what is our x? Our x is now u minus 1. All right, anywhere you see x, we replace it. And what's our x plus 1? That is u. And what is our dx? The x is now du, because we want to integrate with respect to u. And here we can use the simple division here as the integral. By separating these two, we have u divided by u minus 1 divided by u, and everything is enclosed in a du. And if u will cancel u and the result remains 1. All right, and we have 1 minus why this one is 1 over u, everything in du. We can separate this two with different integration, as here is integral of 1 du minus integral of 1 over u du. And if you integrate 1 from the standard, that is going to be the value of the variable, that is u minus. If you integrate this, we have the u and plus c. And here we have x minus 1 as the value of x plus 1 as the value of u, and u is still x plus 1. And here is how to do this. All right, it's very simple, just follow the step. And here is another example for us to solve, but this one is taking the power of 1 over 2, which is also the root. To solve this, we let u to be equal to x minus 1, and by doing that, we change the variable as well. And by changing this variable, we are going to have this one come here, and we have x equals to u plus 1. And we differentiate the new formation, which is the x equals to the u. And we back to the question as integral of the x now is now equals to u plus 1. We bracket it, and x minus 1 is given as u, but everything raised to power of 1 over 2, then du. But here we can open the bracket, u multiplied by u raised to power 1 over 2, so we have it like this, and plus 1 multiplied by u raised to 1 over 2, that is u raised to 1 over 2, and du. But here we can apply the law of indices, as if this is 1 and we take u and we add these two together as 3 divided by 2 du, plus we can take the separate integral of each after we have taken the exponential. And here we have another result here, or the further result to be the u raised to power of 3 over 2 plus 1 when you integrate it, divided by 3 over 2 plus 1, and plus u raised to power of 1 over 3, 1 over 2 rather, plus 1 divided by 1 over 2 plus 1 plus the constant. And by doing the further simplification, The result here is going to be u raised to the power of 5 divided by 2, and we take 2 up and we take 5 down, that is the reciprocal. And here is the plus u raised to the power of 3 over 2 as well, and we take 2 here and we take 3 down plus the constant. But don't forget the value of u is x minus 1. We just insert it in this as x minus 1 raised to the power of 5 over 2, plus here is 2 divided by 3 of x minus 1 raised to the power of 3 divided by 2 plus c. And here is the solution for this. Thanks. And just don't forget the step I take from each question. And here is a takeaway for you, a gift for you. So you can solve it and drop the answer in the comment section. And if you are just coming to my YouTube channel, I made this video for you in an easiest way. Please like, share, and subscribe. Thanks for watching.